Assalamualaikum warahmatullahi wabarakatuh to Cik Muhammad Afdal bin Samsudin. Today, my friend and I will be present about ping-pong launcher design challenge. We are taking subject BMMM 2313 Dynamics and Mechanics of Machines. Okay, we'll pass to next slide to our presenter.
Okay, my name is Muhammad Lokman bin Zulkifli. What is projectile motion? Is the motion of an object thrown or projected into the air, subject to only the acceleration of gravity. That means there is no other acceleration other than gravity. In particular, the effect of air resistance are passive and assumed to be negligible. The object is called a projectile and its pace is called trajectory. When an object is moving or projected into the air, there is initial velocity subjected, which is Vx and Vy. This means that the object will move upward while moving to the front simultaneously. When the velocity is moving to the front, the velocity will remain constant, same with the initial velocity, which is Vx, while the velocity of the ball will change when the ball is moving upward in y direction, where it will reach zero velocity before the object experience downward motion until it reach the ground. When the velocity from initial becomes zero at the air, it means that the object is at maximum height and the velocity will reach equal to initial velocity but in negative value when it is the ground. Okay, I will pass to next slide to my friend.
Okay, thank you, Lukman. And I will present about ping pong launcher apparatus. Okay, my name is Muhammad Syahid Amir. Okay, for apparatus, we use paper cup, rubber bands, tape, 60-degree ruler, ice cream sticks, plastic fork, scissors, and ping pong ball. Okay, why we choose rubber bands? Because rubber bands more elastic and friendly to use, which is make our project progress easier. Rubber band can be easily found around the house rather than spring because spring has many sizes and small spring has small potential and cannot be used to launch the ping pong ball perfectly. Okay, this is our design and setup. You can see on the overview picture, we already use the length that given, which is 1.5 meter from point A and point B, and the height of the launcher, the ball is 6.1 centimeter. Okay, we can see the front view, side view, and back view here. For mechanism, when the rubber band is stretched, it will store potential energy, which the ball will launch when the potential energy is converted to kinetic energy after the catapult is released. As we can see in this video, how it works. Alright, so next is for demonstration video. Okay, let's proceed for calculation.
Thank you, Shahid. My name is Muhammad Daniel. Today I will explain about projectile motion calculation for our ping-pong launcher. We must first analyze the free body diagram for our project motion of our ping-pong launcher. The angle for our ping-pong launcher is 60 degrees. Then we have analyzed through vertical axis and horizontal axis for our ping-pong launcher. For the vertical axis, we analyze that V0y equal to V0 sin 60 degree and we get 0.87 for V0. For the horizontal axis, we have do the analysis that the equation is V0x equal to V0 cos 60 and we get 0.5 V0 for the horizontal axis. Next. Okay, now we go to the next calculation. The next calculation is to find the value of V0, which is the velocity, and the value of the time taken. On the left side, for the horizontal axis, we found that the most suitable formula that can be used is R is equal to S0 plus V0 multiplied by T. And for the solution, we substitute the information that we get, which is R is equal to 1.5 meter, S0 equal to 0, V0x equal to 0.5 V0. And then we will get the first equation, which is V0 equal to 3 over T. On the right side, for the vertical axis, we use formula S is equal to S0 plus V0 T plus 1 over 2 multiplied by A and multiplied by T to the power of 2. Then we substitute the value such as acceleration value, which is A is equal to 9.81, that is referred to gravitational acceleration. Okay, from that value we will get the second equation, which is 0 equal to 0 plus 0.87 V0 times by T plus 1 over 2 multiplied by negative 9.81 multiplied by T to the power of 2. Next. Okay, after that, for the last part of projectile motion calculation, we combine the two equations that we get before to find the value of time taken and the velocity. The value of time taken is 0.72 seconds and the value of velocity is 4.17 meter per second. Next. And then the recorded data that we get is 1.5 meter for distance, 60 degree for angle, the initial height is 6.1 meter, and the time of flight is 0.72, and the last is the velocity, which is 4.17 meter per second. That's all from me. I will pass to the next presenter.
Thank you, Daniel, for your explanation about the calculations. I will talk about discussions for these projects. Okay, for the discussion, the horizontal length, the horizontal distance needs to be traveled for the ping pong ball after launch by the launcher is 1.5 meter, and the height of the launcher is 6.1 cm, but the angle of the launcher is unknown. So we use cup as the height of the launcher, which is 6.1 cm, and the spoon as the launcher to obtain the angles until the ping pong reach the horizontal distance of 1.5 meter. In these experiments, we record the time taken and angle of the spoons for the launcher of ping pong ball to travel the desired distance. Second, the higher the kinetic energy, the higher the accelerations. And lastly, the project motion will pass more kinetic energy when the ping pong will pull way beneath the ground as it poses more elastic energy. That's all for discussions. I will pass to the next presenter to talk about conclusions.
Okay, thank you, Hazi. Based on this project, known that projectile motion is motion in two dimensions which moving along horizontally and vertically at the same time. The velocity along x direction is constant and the velocity of y direction is changing with respect to its position. Also, to the object is at peak height when the velocity of y direction is equal to 0. It is proved by the ping pong launcher design and simulation during the process along with calculations that have been made. To know the angle of projectile needed for the ball to reach the exact distance, we compare every angle and can make a relationship where when the angle of projectile is higher, so the time projectile travel become longer. That's all from us. Thank you for lending me your ears.